Okay, thanks for coming. This is Julian. He's the CTO of Astronomer, the main company behind backing Airflow. Um, Anything else you want to add?
No, I think that's
Yeah, all right. We flew in from New York City just for this. So I appreciate you guys coming in.
yes,
All right,
yes.
go for it.
Cool. Yeah, thanks everyone for joining us today. Like Andy mentioned, my name is Julian. I'm the CTO at a company called Astronomer. I'll tell you a bit about what we do in a minute. And I'm joined by two other astronomers in the room. We have Carter, who runs engineering for us, and then we have Scott in the back, who is one of our biggest investors, plus actually used to be the CEO of Astronomer. I want to keep this pretty collaborative. If you have questions, thoughts, comments as I'm going through this, feel free to interrupt me, put your hand up. I'll also try to ask a bunch of questions to keep folks engaged. Before I get into it, though, I guess out of curiosity, how many of you have heard of Airflow before? Okay, cool. Who can tell me what Airflow is? Gonna make you do my job for me.
You worked on that, right?
I last summer. I think my understanding is that it's like a tool for orchestrating like more complex workflows. And then like giving people like a way to also like monitor the progress of the airflow and like or the workflow and controls and like control stuff.
Yeah, that's exactly right. What did you all use Airflow for?
Automating like some internal workflows.
Okay, nice, awesome. Yeah, so I always like to start out with the next case meme, of course. This one's about where processing latency comes from. You have all these automated steps, and you spend a lot of time to make sure that those are as fast as possible. But then, of course, if you're waiting on a human to do something, it takes a bunch of time. This is exactly the problem that Airflow was designed to solve. So Airflow, if you're not familiar, is the most popular tool out there to write, run, and scale data pipelines. It's downloaded now over 40 million times a month, which is really awesome. About 4 years ago, when I joined Astronomer, it was only downloaded 1 million times a month. So it's seen explosive growth just as data, ML, AI have taken off. It's got 3,300 contributors to it. So at Astronomer, I believe we've written about half of the Airflow code base at this point, but one of the things that makes it so incredible to work with and so widely adopted is it's super easy to contribute to, and a lot of people do decide to contribute. I think there's actually more contributors than Spark, and for a while, like we had passed Kubernetes itself. So really, really active and popular projects. It's got, of course, a bunch of GitHub stars, lots of people active on Slack.
And where the contributors from? All over?
All over, yeah. A lot of like ICs that work at companies that use Airflow will go contribute back like bug fixes, minor features. There are a lot of companies, some of them on this list, that actually have people dedicated to contributing to open source Airflow because they use it so much internally. We, of course, contribute a lot. AWS and Google also contribute quite a bit because they have similar managed Airflow services. But largely, I mean, all over the place, which is one of the things that I really enjoy with working with it. It's used by, I mean, basically every large company in the world to power their data platforms across all industries. So Uber, Stripe, Apple, Ford, Wix, Robinhood, LinkedIn, Instacart, and Bloomberg, just as kind of an illustrative example, all use Airflow to power their data platforms across data workloads, ML workloads, and of course now AI workloads. I mentioned this, it's seen some pretty explosive growth over the last 4 years. We released the 2.0 version of Airflow about 4 years ago now, 4.5 years ago. And that was one of the things that I think helped drive quite a bit of adoption. Again, it's up 30x over the last couple of years. We actually just released Airflow 3.0 earlier this year. Obviously, I hope we get the same 30x growth, but there's only so much you can grow. Airflow is kind kind of an interesting tool because you can use it to write and run effectively any workflow. We'll jump into examples here in a second, but it's effectively like Python code that you can break out into larger pipelines and individual tasks. It comes with a lot of kind of pre-built utilities and nice experiences for working with data in particular. But amongst our customer base, like we have Fortune 5 companies that are using it to power all of their payroll. And we have large gaming companies and casinos that use it to power all of their regulatory reporting. So, data is very broad, fortunately. So, the four kind of main use cases, though, that we see are ETL and ELT. So that's taking data from one place, loading it into another place, doing some transformation on it, and then finally putting it in a final place. We see a lot of ML ops, so the actual like life cycle of how do you train models at scale, how do you retrain them, how do you measure model drift, how do you deploy them. A lot of operational analytics. So what that means is like a lot of companies are now feeding data back into their product. Like at Astronomer, for example, we have a set of dashboards and analytics that just live inside of our products. Those are, of course, powered by Airflow pipelines. And then we've also seen over the last 2 years, particularly, a lot of AI and LLM workflows. Because oftentimes to do those in an interesting way, for your company, you're never just taking these off-the-shelf models and, embedding them in your product and calling it a day. You're always supplementing them with some data that you have unique access to, either by loading that data into a vector database, which Airflow can help with, or by fine-tuning or in-context learning. So we've seen a lot of those over the last couple of years. But I wanted to talk about like what it actually looks like to interact with Airflow. So kind of the core concept behind Airflow is this idea of a DAG. Can anyone tell me what DAG stands for?
Is CMU.
Good. Yeah, so I won't spend too much time on this. I think the one important point to note is you cannot have cycles in an Airflow pipeline, which means you have certain guarantees around execution order and how long it'll take. But a DAG is fairly synonymous with a pipeline in Airflow. Airflow gives you two effectively Python decorators that make it super easy to turn normal Python code into an Airflow pipeline. So looking at this example, we have a pipeline that gets manatee jokes. And you can see at the top, we're importing from Airflow's SDK the DAG and the task decorator. Those are the two important things to highlight here. And then you have a main function for your DAG that gets the decorator. So I can tell it when this pipeline should start, how often it should run. There's a list of like 50 things you can go supply to kind of customize how the pipeline runs. And then right below it is the @task decorator, which you can use to decorate a Python function and turn it into an Airflow task. And then one of the other things that's made Airflow quite popular is it comes with a bunch of pre-built utilities for working with common data tools. So down here, we're importing something called the bash operator, which Airflow is kind of taking care of how you actually go run bash commands from Python. So you only have to fill out what the command is, and it'll take care of like spinning up a subprocess and output parsing and all that fun stuff. There's about 1,500 pre-built operators just in the open source community. And what that means is, if you're writing these pipelines, if you're working with common tools like Snowflake, Databricks, Fivetran, dbt, et cetera, you shouldn't be spending much time on actually integrating systems. You get to spend all your time on business logic. So it is, again, because it's one of the most popular data orchestration tools there is, and you have like 3,000 people all contributing to it, it means that whenever there is a new tool that gets kind of popular, Airflow ends up adopting it in a form of operators. So for example, now there's like OpenAI operators and Weaviate operators and kind of this new class of AI utilities that were all built by the community. Oops, forgot this was a build slide. So DAGs run periodically. They're always doing some sort of incremental data processing. They run automatically. The idea is once you kind of deploy a pipeline, it should just run on its own, and you only need to intervene if things are actively going wrong. Tasks, on the other hand, you build them to be idempotent. So given the same inputs, you should always have the same outputs. That's important because tasks are often retried in Airflow. Like if you hit an API rate limit, or your machine runs out of memory, or some external service goes down, you want to make sure that you get the kind of same results, atomic, modular, and that's where you end up putting all of the dynamic logic. So this is kind of what an example DAG in Airflow looks like. We have a bunch of tasks. You can also do things like make task groups to go group things together. This one is a typical like ETL plus ML pipeline. So at the beginning, one of the pre-built Airflow utilities is branching. So you can decide, given the output of some Python function, which branch of the pipeline you want to run. In this case, it looks like it's just changing where you extract data from. Then we're using the SQL operator to run some SQL. It has a bunch of pre-built utilities for doing things like data quality checks, and then training some models and generating a report based off of it. So this same kind of concept and structure can be used regardless of what type of pipeline you're writing, whether it's some internal workflow you want to automate, whether it's an ETL pipeline like this, whether it's training a model, whether it's some AI workflow, you always use the same primitives. So a task ends up being a node in the DAG. They should always be atomic. Not everyone follows that rule. And then every time a task runs, you get a task instance. So that's like an individual instance of that task that was run today or yesterday. So it's your DAG, your task, and a point in time. Again, it's Python code, so like you can have your tasks do whatever you want, make an API call, kick off a Databricks job, run a query in Snowflake.
What does atomic mean? Like how strict is that label that the coder has to adhere to?
I would think about it like checkpoints almost. So every task in the DAG should be thought of as its own checkpoint, mostly for like retries and durability. So for example, you could go take something like this, and this could, in theory, be a single task. Like there's nothing stopping someone from saying, I'm going to go take all of this logic and just write it in Python. But what happens when you break it out like this is you get much more granular observability. So at a glance, you can see where, like if something failed, where did it fail? What downstream of it is now not going to run? You can do things like look at the logs and configure alerts on the individual task level. So it might be a different person that cares about data extraction than cares about like the report not getting finished. And also, like, as things retry, you want to make sure those retries are happening at the most granular level. Because if you get to here and you start training some models and something fails, you don't want to go back to the beginning, right? Because you've already ingested your data, you've already run your data quality checks, like the data is good, so you want it to pick up just from here.
So streaming systems have this where they require the tasks or the equivalent of operators to have certain patterns, and then they will say, now I can guarantee that the data flow is going to have exactly one semantics or at most one semantics. Does it go that far, or it's just like at the retry level, saying, okay, for example, if I have to retry train model B, then it's up to you, the programmer, to ensure that that retry, if it has any side effects, those are cleaned up by you, not by the orchestration engine.
Yeah. So it's a great question. Airflow is a very flexible system, and that can be a double-edged sword at times. Like the nice thing about that is we see people using Airflow for almost everything. The downside is it can oftentimes leave a lot of that like orchestration logic up to the user. That's why I say like tasks in theory should be idempotent and atomic, but there's nothing stopping someone from writing a bad DAG. Of course, we like at Astronomer and kind of in the open source community, spend a lot of time helping make sure that people understand exactly what they like should and shouldn't be doing and how they should set things up to be retryable and like what it actually looks like to write a good DAG. But again, it's just Python code at the end of the day, so it can be sometimes tricky to do correctly.
Thank you. So if I understand correctly, right now, this is kind of left up to the implementers to decide how to structure the tag, but there's also some recent work, for example, with Jupyter notebooks, where it can automatically detect if a variable's dependencies have been modified. Is this a direction you see yourself moving towards? So
Yeah, it's a good question. So the at task decorators were new in Airflow 2.x. The nice thing about the task decorators is I don't have an example of it here, but if you pass the output of this to another task decorator, Airflow will automatically create those dependencies for you. It's only when you're using the more traditional operators that like you have to manually define. So Airflow tries to infer what it can based on how you're kind of passing data around. But oftentimes, like Airflow itself might not be able to know, right? Like if you have one task that runs a Snowflake query and another task that runs, let's say, another Snowflake query to like check data quality or calculate some metric. It's like you as a human know that those two things need to run sequentially. Maybe there are some things that we can do to try to like parse the SQL and come up with something there. But yeah, Airflow tries to infer it when it can.
thanks.
So as far as I understand, there's a distinction between uppercase B DAG, like what you guys call DAG, and what is actually like in fact acyclic graph. So do you relax the requirement for it to be acyclic in that, like, is there some notion of like a back edge in your, like you mentioned retries a little bit too?
Yeah.
Does it imply that you maybe go back in the control flow?
Yeah, it's a good question. So let's see if I can find that example tag again. So within a single DAG, you can never have a cycle. Like that is something that Airflow imposes. If you try to write code where there is a cycle, Airflow will say, hey, there's a cycle, you can't do this. Now, that being said, there are some clever ways you can try to work around that. Like you could have a task at the end here that says, trigger the first task in the pipeline and let it run again. But it's always a little bit like we generally don't see people doing that type of thing all that often, just because it can create a lot of confusion about like why things are running the way they are. Retries all happen at the individual task level. So if a task fails, there's a parameter you can specify, which is how many times should it retry and things like exponential backoff. And if that parameter is specified, if this task, for example, were to fail halfway through, everything else would continue running. This would go from like queued state to running state to Airflow has a special state called up for retry. And then it would go back to running and then potentially back to up for retry and back to running and then either failed or success.
So you don't see much like demand for that kind of behavior?
People ask questions about it for sure. But I've never seen something that kind of can't be worked around. Yeah. Let's see. So decorators and operators, we talked about a little bit. Airflow publishes a set of them that are kind of community maintained. Oftentimes we'll have like different vendors come in and build the Airflow integration. Like for example, the AWS team has a very real incentive to make sure all of the AWS stuff works well with Airflow because it's downloaded 40 million times a month. There's 70,000 companies out there. using it so it becomes a very nice distribution mechanism for things that they're doing. Yeah, there's 1,500 of these. We publish a registry of like, if you're trying to do something in Airflow, you can first check it to see like, has someone already done this before? And it's super easy to contribute new providers and operators too. So we see a lot of activity here. Task groups we talked about. It's effectively just a visual grouping, like it doesn't actually really provide any functionality. The most common ones are people will build their own custom DAG groups just to help like show things in the UI better. There's a DBT task group where you can take a DBT project and it'll automatically turn it into a full like Airflow DAG or task group based on the structure of everything inside of DBT. And then same thing with Databricks workflows, like you can point Airflow at a Databricks workflow and it'll kind of dynamically render what's happening inside of Databricks. Assets are something new in Airflow 3. So one of the things that we've noticed is 10 years ago when Airflow was built, people used to think of things very much in terms of like processes that were getting triggered. It was like, go run this job in this system and then run this job in this other system. I'd say when people work with these like data pipelines and workflows today, the mental model has kind of shifted a bit. Like you're thinking a lot more about how you're constructing data sets and moving around data. So Airflow introduced this new asset decorator where it creates a DAG for you under the hood. But all you have to do is define the schedule and then like the logic that actually needs to be run to create that asset. So this is kind of a fake example, but you could imagine maybe one of these is like a snowflake table and you would put the SQL in here to materialize that snowflake table. Because the nice thing about this is you can do asset-driven scheduling in Airflow. So all the examples so far have been time-based schedules, but you could also say like this asset depends on these other two tables. So when those are both successfully updated, then I want to go run this. And it just helps move things into a more like real-time
A
world.
mix of cron jobs and database sprinters.
Yeah, that's a good way to think about it. You can also hook up Airflow to like an event bus, Kafka, PubSub, that type of thing, and say, run this whenever I have an event of this type. So the big theme with Airflow 3 was people started using Airflow 2 in all these interesting ways that we didn't anticipate. Like people had kind of hooked up their own event trigger type mechanisms. So we took a lot of the different patterns that we were seeing in how people were using Airflow 2 and kind of formally expressed them in Airflow 3. The goal is to make sure that as the workloads continue changing over the next 4 or 5 years, Airflow 3 is still the standard for those things. So that's kind of the like user interface or kind of SDK of Airflow, what it looks like to write a pipeline. There's a lot that goes into running these pipelines at scale. Like we have customers that are running literally tens of thousands of pipelines. And so making sure you have a system where those pipelines can all run together with dependencies on each other and you don't get like these noisy neighbor issues. You can properly separate compute for these things. There's a handful of components that you need to run Airflow. The first is the scheduler. So this is like the heart of Airflow, if you will. The scheduler effectively has a loop that it runs. It's constantly checking its metadata database to try to find DAGs and tasks that need to be run, and it goes and tells an executor about them. So again, it's just sitting there constantly looking for work to be done. And we'll run those as the dependencies get fulfilled.
How sophisticated is the schedule?
It's fairly sophisticated.
Okay.
Because you can configure a lot of things in Airflow. Like you can now do event-driven pipelines, data set-driven pipelines, scheduled pipelines, ad hoc pipelines. Plus you can supply a lot of like system level configuration about how those things should run. So you should only ever have 10 tasks of this type running, and certain DAGs, you can only ever have one active run per DAG. So it is kind of where all the business logic to translate that configuration into the system lives.
It sounds like it's like a fair schedule with a bunch of constraints.
Yeah, I think that's a good way to think about it. This
solution developer task is it like a process or like a VM that's fine, but
it's a good question. So I mentioned the scheduler, when it says here's a set of tasks to go run, it hands it off to an executor. So the executor is responsible for taking the user's code and turning it into like actual tasks that are run. It's a very pluggable interface, so people have built lots of schedulers over the years. The two most popular are the Celery executor, where you're running multiple tasks on a single machine as sub-processes, especially when Airflow is doing things like triggering SQL queries, things that are like very light on compute, and you don't have to worry as much about resource utilization and care more about speed than you do about isolation. The other more popular one is the Kubernetes executor, where every task gets its own Kubernetes pod to be run in. That's nicer because you get like obviously stronger isolation, but it takes a couple seconds to spin up and spin down Kubernetes pods. And if you're using something like the Kubernetes executor, you can also specify like a different image for every task to be run on. So it's super common, for example, like if you're training an ML pipeline, the like packaging ecosystem for that can be very weird. It's oftentimes easier to like build an image to go train a model on, because otherwise you'd need to kind of share a Python environment with everything else.
you mentioned the binary will follow, right? So how do you avoid that in the future? Because all the process is much accelerated.
To some extent, you don't. Like, it does happen where if you don't have things configured properly, or you try to run compute on Celery, if one task takes too much resources, like you do run into the noisy neighbor issue. So this is where like it kind of depends on the type of workload that you're running. Again, if you're doing things like triggering a bunch of SQL queries, the chances that those noisy neighbor problems become painful is relatively small versus if people are actually running like data processing jobs within Airflow.
It's kind of blending Andy's earlier question with what you just said. To what extent is the scheduler aware of like a task's expected runtime duration? Does it try to figure this out, or is it something a user tries to do?
That's a really good question. Today it has no knowledge. So like the scheduler is responsible for purely like finding what needs to be run and handing them off to the executor. At Astronomer, we just rebuilt a new, or I say built a new executor where we're thinking about doing that type of thing. For example, the volume of data that you process over time might slowly change, right? Generally, it goes up. And having an executor that can look at the run history and make some judgments about what to do with that task could be very helpful. At the same time, like it's a very tricky problem to solve. So like, for example, we have a lot of retail customers, and Black Friday weekend for them always generates a bunch of anomalies. Weekend to weekday patterns also look interesting. Start of week, end of week, and like because everyone's workloads are different, it's tough to like build kind of one executor set of models to try to accurately predict across the life cycle. If that's a problem that sounds interesting to you, come talk to us because it's something that we're looking at solving. So I mentioned, yeah, scheduler hands off to executor. Workers are responsible for actually executing the tasks. You have things like Celery workers, Kubernetes workers.
So maybe one more question.
Yeah.
Schedule is super interesting.
Yeah.
You're getting all these questions.
Yeah.
So if I'm running in the cloud,
Mhm.
if I have one of these modern AI workloads, there are
Mhm.
some tasks I want to communicate and tell you, hey, I need at least this type of a GPU for it. So how do I communicate with that? It's already super hard to do that in Kubernetes when you have to write that
Yeah.
mapping. So is there some automation to that, or am I, as the developer, responsible for giving you that mapping and the node? Or can you go find those for me if I just tell you kind of what I need?
What you need. Yeah. Another great question. I should have just done a deep dive on the scheduler for today. So Airflow has a notion of worker queues. Oftentimes within a single Airflow instance, you might have like lots of different workload types, right? Some of them might be running SQL, some of them might be training ML models, some of them might be doing inference on an LLM. And worker queues are how you define the infrastructure that those things need to run on. So oftentimes you'll have like a default worker queue, which again has some defaults that are like
So
good for everything.
I as a developer also provide the compute and storage resources behind it, or how abstract is the definition of a worker queue?
Yeah.
And what is exposed to the schedule?
What's exposed to the schedule?
The scheduler just knows about what worker queue it is. The executor handles the actual delegation of
So presumably I'll
work to
come
that
with my
queue.
containers, and then the worker queue, I'm just putting task forward, there's some binding to the containers, right? So
Yeah.
but okay.
It
But maybe
it depends.
yeah.
Yeah, so it depends on how you run Airflow. Like we at Astronomer run Airflow on Kubernetes. So different worker queues get different deployments in Kubernetes with different auto scaling groups.
Yes, for a DAG.
You're configuring what, you're saying what the resources are,
Yeah.
Yeah. Or maybe I just want to say, here's my DAG. I can tell you I need a GPU with 80 gigs of HBM for this. I don't care. Just give me a regular CPU.
Yeah.
You provision it and run it and find me and I just deploy it.
Yeah.
Right, so you could, with Airflow 3, you could point some things, like I want these things to run on GPUs and I want these things to run on, this over here. It's a really interesting problem though, it's funny you're poking on that, because that's something we're actually spending a lot of research time on internally, is like, how could you abstract it out where the user doesn't have to be specifying the resource footprint, because the resource footprints change over time.
Yeah.
One of the things, the biggest cause of task outages is probably OOMs.
Yeah.
And so what does a ops person do when they see an OOM? It's like, well, just double the memory.
Yes.
And I'll leave it alone. It's just a one-time spike, and there's a lot of waste left. So
and sometimes I don't know, right? I don't know what I need. I think I know the GPU, but until my training task runs, I don't know if I need one of them or four of them, or I'm changing dynamically even for the same DAG based on what shows up, what data shows up, right?
Right.
Yeah.
And so they'll often over provision just to make sure things don't fail. Right.
That sounds like a really interesting direction.
Yeah, there's a lot of resources being managed by this across the world, actually. So
yeah, you can get pretty clever with it too. Like to Carter's example of it runs out of memory, so you just double it.
Or you
like,
can be like, I can find a spot price for this, so that I know it runs for an hour. Stuff like that.
Yeah. Especially if you know something is retryable, like your ability to put it on a spot instance looks very different. So this is where I think you can build over time a lot of cleverness in the way you provision and manage infrastructure. And infrastructure, of course, is very expensive. So anything you can do to make that easier to manage and kind of more intelligent on its own over time, I think it's super interesting.
Do people still run yarn?
I think there are old systems, but no one modern sounds. But
I've run into it a handful of times, but mostly for cases like that where we have some customers, for example, who will go build their own GPU clusters and look at something like Yarn or Slurm to.
Honestly, since it was Cloudera, is still around and kicking around. So there is young jobs, probably new jobs, all that stuff. Moving around somewhere.
Yeah.
Just talking about Patty's question of sophistication of the scheduler. So, for example, if I request in my cluster, I want 4 CPUs or 5 CPUs, will it give them all to the same human mode, or will that not be handled at all? Like provisionally, I would want them all to be on the same human mode, right, to avoid memory bandwidth issues.
Yeah, it'll do that. Like your task will run in its entirety on a single node.
That allow you to pin on this particular CPU as well. So if I retry it, I just keep it running on the same CPU or just start like get
He's saying he wants
Oh,
4 cores in the same socket.
oh. Airflow itself doesn't do a lot of things at the infrastructure level. That's where, like, at Astronomer, because we run it on Kubernetes for our customers, like we would go look into that type of thing, or the Amazon managed airflow service like runs on EC2 nodes. Because airflow is designed to be very flexible, it tries to not take very strong opinions about what the infrastructure looks like.
Man, running Python, they don't care about numeric regions. I do this kind of stuff.
Yeah, you'd be calling out to, like, if you care about that, you'd be calling out to something else that's the managing that intense compute. I guess it's just it's a scheduler, but it's like, it's, very different concerns with a CPU scheduler. And it's
Yeah.
different, different epochs in time,
Yes, yeah. The next component to talk about is the DAG processor. So Airflow, like as the scheduler is working with all of these pipelines, it needs some kind of formal definition of a DAG, some structured representation of the pipeline and the tasks. So the DAG processor is what's responsible for taking code like this and effectively turning it into a JSON object that gets written to the database. So that happens generally once when you deploy code, and then from there on out until you're actually running the DAG, Airflow treats it as a JSON object. The metadata database is the only database that runs with Airflow, so it's where you store all of your DAGs, all of your runs, all of your tasks, all of your task instances, different things like permissions. I think it's pretty much what you'd expect. And then all interactions from like user code to the Airflow system goes through an API server. So when your tasks are running, if they need to fetch like certain secrets or connection information, it'll go through this API server to the metadata database.
Is the metadata database custom to Airflow or is it off the shelf? And if it's off the shelf, don't say what it is just yet.
Okay.
You can guess.
98%+ of people run the same type of metadata.
Is there a default one that Airflow comes with?
Yeah.
Let's take a guess what it is.
RDS.
Mongo? Who said Mongo? Oh, yo.
Postgres, it's gotta be Postgres.
Any other bets?
SQLite.
Yeah, I think it's SQLite, yeah.
Postgres.
Oh, all right.
With that server.
Maybe it should be sometime.
It's running.
So
The default SQLite?
if you run Airflow locally, it comes with a default of SQLite.
Okay.
But when you end up running it as a distributed system in Kubernetes around EC2 or something,
All the
then
time.
Yeah, right.
Yeah.
It's a separate process, you probably are putting into separate.
Yeah. We have a handful of customers that run MySQL. I think with the API server, it helps you plug in different databases.
Why do you think it was Postgres?
Because you're talking about orchestration and all of that stuff, and you don't want like that code to be messing up with something else, right? So you want the abstraction of the data that's not to hit each other. At Postgres is really common, right? So it would make sense in deployment to go use Postgres. Because everything is API based, all of that stuff.
Or Greenclaw.
There you go.
There you go. All right, for the kids.
That's an inside joke.
That's the better on Greenclaw in the back. And they don't know what Greenclaw is though.
That's like
He knows Orca. He's like,
Yeah.
Oh, there you go.
Sorry, keep going.
No problem.
He read the Orca. Awesome.
The last component to talk about this was
We are not gonna let you go off this slide. This will be your last slide.
yeah, good.
Actually,
So in some systems, setting up the metadata database ends up being a bit of a bottleneck.
Mhm.
In Airflow, is it kind of like perfectly fine, not much of a bottleneck?
It is the bottleneck. That and the scheduler are the two things that people have to pay particular attention to scaling. It used to be the case that before Airflow 3, things would talk to the metadata DB directly. So every task that runs would open a connection to the metadata DB. We of course do like pooling and other things to make it easier. But for kind of scalability's sake, now I think in Airflow 3, the API server is going to be the thing to pay attention to because it is designed as kind of the proxy between user code and the database.
And when you mentioned proxy, am I making a literal proxy here that you have?
No, it's I think it runs like Fast API or something. And exposes an API for working with like the Airflow objects.
Maybe last question on this slide. Where does the telemetry data sit? That goes outside of all of this, right?
Yeah, so Airflow itself doesn't come with any opinions about how you do observability or telemetry. It has things like OpenTelemetry instrumented inside of Airflow.
Does it spit out automatically log lines and
Oh.
like that?
It does. By default, those just get written to like the container they're running on.
In some directory, some file.
Yeah, exactly. At Astronomer, what we do is we take all of those logs and end up shipping them to blob storage after something's done running. So you get things in real time as they are running, and they get archived to cold storage. We also have a lot of customers that'll forward logs to like Datadog or Splunk or other observability tools if they have like it might be helpful to see your Airflow logs and your Spark logs in the same place because Airflow is oftentimes trigger something like Spark.
Thank you.
One of the more recent components that was built, I think like halfway through the Airflow 2.x versions was the trigger. So the idea here is like, if you have 1,000 tasks that all kick off a Snowflake query, and each of those Snowflake queries take an hour, it is inefficient to hold a sub-process open that's consuming resources for the entirety of that query. What the trigger is it's one central component that different Airflow operators can like defer work to the trigger. So for example, what happens with something like Snowflake is the worker itself will kick off the query. So it'll run your user code and get back effectively a query ID. And then that process moves to the trigger where instead of holding something open, you're checking like every 5 seconds or something, has this query finished or not? So this helps like with resource utilization, especially because Airflow oftentimes is just scheduling and orchestrating external tools versus running.
Is that different than in the previous one? You had this decorator for running basically a periodic job or something that like a trigger, or is this a completely different functionality?
Completely different functionality. Yeah. I actually don't know the history of why we called it the trigger. Yeah.
Who opts into it? Is it something the implementer of some code has to say?
Good question. Yeah. At the operator level, you effectively specify some parameters and some functions that indicate to Airflow something can be deferred to the trigger. And then users of the operator can either specify, like you can set a global default to like defer everything you can, or like opt in individual pipelines and DAGs, pipelines and tasks. I want to run through like what it looks like to build out a typical data platform because I think it helps build some intuition around like why these things get so complex. Like I mentioned, some of our customers have tens of thousands of pipelines running, which might feel like a lot, but I think when you get into the weeds, it makes a little bit of sense. So Let's imagine for a second, like we all get hired at some big company to build out their data platform. And the CEO comes to you and they say, hey, I want to understand how many monthly and daily active users we have on the platform. Right? So you say, okay, great, no problem. Like let's say we're some e-commerce that might look something like this. So CEO comes to you and they say, how many orders did we get yesterday? And you say, oh, no problem. Let me just log into Postgres and run this query and I'll tell you how many users we got or how many orders we got. But then the CEO comes to you the next day and says, how many orders do we get the next day? How many orders do we get? And so you say, okay, it would be nice if like I could just schedule this to run and maybe even put it in a dashboard for the CEO so they don't have to keep asking me. So you say, great, I'm going to go use some BI tool. And instead of the CEO coming to me, they're going to come to the BI tool and they're going to look at my orders dashboard. So you go hook your BI tool up to Postgres, and you start running into some problems. What type of problems do you think you would run into with this setup?
Things failing,
What type of things?
network down,
Mhm.
connects,
Mhm.
stuff like that.
Yep. What else?
Duplicate work.
Yeah, say more.
So for example, different employees have queries that might be overlapping significant parts of their computation.
Yeah. What if Postgres is the backend of your application too? What might happen? Like, what if people start spinning up their own dashboards and they don't know how to write SQL very well, so it ends up taking a lot of CPU and memory from Postgres. Like, you might face some user degradation, right? Postgres is now going to be slow. So you say, okay, I don't want my analytics workloads in the same place that my production workloads are, right? Like we have our operational database that's great for operating. Let's go spin up a separate analytical environment. You say, okay, this feels simple. You know, everybody uses Snowflake, so I'm going to use Snowflake. I want to get all my Postgres data into Snowflake so that I can go hook the BI tool up to Snowflake instead of Postgres. Without Airflow, how would you do this? Like if you had to do the state and you didn't know Airflow was a thing.
To be easier with Kafka.
Okay. Anyone else?
Fivetran.
Yeah. Yep.
Lambda function in AWS and let it run periodically.
Yeah.
Yeah.
That was what I came to, right? Like Debezium and Kafka, like that's nice if you need real-time data, but like the CEO logs in every morning. He doesn't need it updating constantly. So you say, okay, great, this is pretty easy. Like I'm gonna write some Python code or TypeScript code or whatever you can run on Lambda and say, I want to get everything from my orders table and write it to Snowflake. Fairly straightforward. You can schedule a Lambda and you can set it like you can add in some code here to say, send me a Slack notification if this thing ever fails. You can get pretty clever with it. And then your marketing team comes to you and they say, hey, we have all of this marketing data on who's looking at our marketing website and who we're serving ads to. It would be great if we could also have that data in Snowflake so we could see, like, does that translate to more orders? And then you want to see, like, are people actually paying you for the orders? So you say, okay, great, we have all this data in something like Stripe. I want to pull that into Snowflake. And you know, you have lambdas stood up, so you just like build a couple more lambdas. This is where you start to run into some issues. So like if something goes wrong, it can be very opaque, right? Like you can do your own custom Slack notifications or email notifications or whatever. It can also be tricky because managing dependencies amongst Lambda functions can be hard. Like, what if you wanted to say, hey, from Postgres, our application database, I know what customers I have, and I don't want to pull in all of our marketing data. I only want to pull in things for customers. Like, maybe this thing runs at midnight and that thing runs at 1 a.m. And hopefully you never have issues, but that's not quite how it plays out in reality. If you make this complex enough and you keep building enough stuff around it, you start to have something that looks like Airflow. Like this is how Airflow kind of came to be. It was actually originally built as an internal tool at Airbnb because they were running into these types of problems. That plus all of the existing orchestration tools were very like config based, drag and drop based, which is great if you have very simple pipelines, but as your workflows get more complex, being able to express those as code is very important. So you say, okay, great, I'm going to move all of these things to Airflow. I'm going to have my product ingestion pipeline first, and then I'm going to go run my other ingestion pipelines. Then I want a Slack notification when everything's done. This is great because you can move from simple to complex in the same tool with the same primitives without running into many issues. So, the marketing team, let's say they want their own kind of set of dashboards specifically for conversions, for the funnel of how people get into the product, for how their ads are performing. So you say, no problem, I can spin up a new pipeline that runs whenever my marketing ingestion is done. I'm going to run some data quality checks just to make sure everything looks good, and then I'm going to go spit out a bunch of models, metrics, calculations. And the nice thing is like you can have separate teams that own individual pipelines. So it might be like the data engineering team that's responsible for this, and maybe the marketing team goes and hires the data analyst that can build out this. And we see like a natural progression from kind of the basic analytics and ETL to doing more advanced like data science, ML, AI stuff. So, once you have a data platform up and running, you have your data constantly coming in, you have some basic dashboards built out, you can start to look at more interesting things. So, you might want to train models to try to predict churn risk, right? Like you have probably lots of interesting data about it. You might want to try to forecast inventory demand based on sales and kind of leading marketing data. You might want to build some product recommendation system. These are all like data workflows under the hood, so you can do those types of things in Airflow. Like you run into this set of problems or things to go kind of solve when you're building out ML pipelines. Like you need data prepared in a particular way. You probably want to generate a bunch of features that like based on the data, you want to do a lot of experimentation, you want to train your models, you might have different compute requirements, versioning, monitoring, like all this fun stuff. Orchestration helps a lot with all of these things, especially going from like some local Jupyter notebook where you've like POC'd a model and you want to actually go put it in production where it kind of can continue to be deployed. So this is an example of like a very common pattern that we see from people deploying ML models. I'll start from the top. So you oftentimes have some like feature construction pipeline where you might, again, like it's always good to start with data quality checks. You want to make sure you catch those things early. You want to go construct some features based on the data and then save those back someplace. And this is like a pipeline in and of itself. And then whenever your features are, done getting computed for the day or week or hour or whatever, you want to go train a model, right? You probably also have an existing model deployed. So you train a new model, you test it against some test data set to make sure there's no obvious regressions. It's pretty common to like have some method of comparing your existing deployed model versus a new one that you've just trained called champion challenger. And then you probably want to branch and say, okay, I'm either going to deploy this new model because I can prove it's better, or I just want to keep the current one, right? Like it's not much better. And then you also want to think about model drift, right? Like as the data and patterns of people using your application change over time, the model that worked well 2 weeks ago might not work super well today. It's very expensive to train new models all the time. Like you might not want to train a new model every hour, every day. You might want to only do it when you feel like you need to. So people will create like model drift pipelines to say, go check and see how the existing model is running in production. If you see some degradation or some drift, you can go kick off the training run. This is also, I'd say, like very interesting in the LLM space today too. So like Cursor, a couple maybe last month released some new like online pipeline or online model that they use for their tab model. So like Cursor, as you're hitting tab or it's proposing changes and you're not hitting tab, is getting new, very interesting data all of the time. And it used to be the case that they would go through very large training exercises every, periodically. But they released something that probably looks something like this, where it's every 4 hours now they roll out a new version of their tab model based on the data that they've like received over the last 4 hours. And so very quickly, like you end up in this world where you're pulling data in from like lots of different places, your application databases, maybe you go buy some data, maybe you have third-party data sources like marketing data, web traffic data. You need to go oftentimes centralize a lot of that data in something like Snowflake or Databricks, or people use like BigQuery, RDS. You'll have some analytics and reporting use cases on that data where you'll want to do some transformation and some visualization. You might actually go sell that data to somebody, right? So that's another interesting use case. You might try to train some sort of predictive models. And so these data platforms get very, very complex, but when like every individual piece of it looks kind of as simple as this, it becomes very easy to understand, work with, and kind of see how everything ties together. And like this is what I mean, some of the largest and most interesting companies today are doing. So, we had an Airflow conference a couple weeks ago now in Seattle, where OpenAI talked about how they're now running, I think it's like 7,000 pipelines all on Airflow for, everything from like their internal dashboards to even like some feature development and like model training. So Airflow is very much here to stay. Like we think obviously it's going to get even more and more popular over time, just because of all the interesting types of things you can build around it.
So I just want to kind of comment, I'll throw in the end because you went into that, the ML piece. And
Yeah.
that's one of the things, that kind of brought me to Airflow and data and orchestration, things like that. Was the previous job was in a very ML driven company. And there was, first of all, these pipelines are incredibly complex and multi-layered, and different teams do different pieces to help together. But also, like, there was a need to standardize these things too. You can write these things out in code, but when you're trying to get the entire organization to backfill data, for example, for a model training in a very particular way that's repeatable and monitorable, then things like this become absolutely essential and really accelerate the whole process. So I was not at all surprised, when we saw a presentation from OpenAI, when they're like, "Oh yeah, we run 7,000 DAGs, and it actually is mission critical to everything we do here." So it's a very exciting space, and in terms of like getting how do you kind of schedule across a large distributed system, and I kind of think of it mentally as like a distributed operating system in a way.
Great.
Yeah.
Is the actual internal running status of a task observable to the executor itself? Like, can it make decisions based on why a task failed to the rest of the system?
I'd have to double check to be sure. I know the task logic itself does have access. So like one of our customers, for example, set something up where if a task ever fails, they just retry it with twice the memory automatically. And like for better or worse, it works very well for them. So I imagine that the executor has access to that data, but once the executor is kind of spun up a worker and handed off the job, I think its job is pretty much complete. Any other questions?
Do you have any statistics on like the average pipeline depth or the
For
the progress?
Average is probably quite high. We have some people that like will go put 1,000 tasks DAG, which is like at a certain point, it's like not that useful. And I think if you ask them like if they were to do it again, would they still do it that way? Probably not. We also have some like a lot of DAGs will just have a single task. Probably averages 10 to 15, maybe.
Yeah, I mean, your last slide, I thought was a good, the correct way to do it is to break, oh, sorry, this one. The correct way to do it is to break down into logical units and then have them trigger each other.
Yeah.
And I think that's going to be, that's an easier thing to do with the trigger capabilities, the event-driven capabilities to have kind of the right type of architecture. I think before people did build mega DAGs because it was primarily scheduled kind of like a cron job, and you did kind of throw it all in there. But this is 3 DAGs, even though it looks like one, and it's much cleaner and easier to maintain, obviously.
So arguably in a way, these are kind of like more suited for task groups, whereas each task group itself can be a very much broader set of tasks so that you have better retry capabilities.
This is a good question. So the thing that you can't do with task groups that you can do with something like this is run things on different schedules. So for example, like you might want to construct your features every day because you want those to be up to date. But maybe you don't want to automatically train the model every time you have new features. You might say, actually, this model training has no schedule. I'd never want it to run on its own. I am either going to log in and click run because I have some instinct that it's useful, or you can do like event-driven pipelines and say, hey, whenever we notice some drift or some degradation, then go trigger that pipeline. Yeah. And Airflow has nice ways of like looking at all of your cross pipeline dependencies too.
I'll say I have seen DAGs that were well written that were still like 200 tasks in size. And those were like really complex ML models that were pulling in, literally hundreds of different features from different sources, things like that.
Yeah.
They were logically part of a single unit. But it's a mess to reason about.
Yeah.
Imagine.
All right, one more last question. It's just I have a question about like the interface interacting with the Airflow.
Mhm.
Like, so you see like in the ML system space, like people move from TensorFlow to like PyTorch in a way where like you specify the control flow instead of like the branching decorator stuff.
Yeah.
You will feel more natural to you directly compose this logic in Python. What's your guys' take on like this programmable?
People do lots of very interesting things with Airflow. I would say it's very rare that someone takes Airflow out of the box and just uses it in the vanilla way. For example, like one pattern that's super common is like the factory pattern of you have one Python file that looks at a bunch of like YAML config files and renders each of those as a DAG. You could also build kind of your own set of abstractions that compile down to an Airflow DAG. I'd have to go back and look at like the PyTorch example specifically. But Airflow tries to be unopinionated where possible and instead introduce room for people to take their own opinions.
Thanks.
Makes your life harder.
It does, it makes our life a little bit harder. But now there's 70,000 people using it. So
Of course, yeah.